Hi guys, welcome to God Academy. In this lesson, I'll be taking you through complex conjugates and their complex numbers. In our previous lesson, we looked at modulos and arguments. We looked at the Argand diagram and how to determine the right quadrant configuration. In this lesson, what is complex conjugates? So when you say complex conjugates, given a complex number z1 which is equal to x plus iy, then to find a complex conjugate, you simply negate, okay? You negate the imaginary parts, okay? So my complex conjugate is simply equal to x minus I, y, as simple as that. You just put a bar on it showing the complex conjugate and it's giving us x minus I, y. Let's solve some example here. So if I give you number one, find the conjugate of z is equal to a plus 2i plus 3ib, right? To find the conjugates, you always make sure you have grouped all your imaginary parts at one point. So here I'm going to have a plus, now imaginary parts I have 2i plus 3ib. The next thing I have to do is z is equal to a plus, I factorize I out, I get 2 plus what? 3b, right? Therefore, my complex conjugate is simply equal to a minus I 2 plus 3b, and that is all. Let's try a second question, number 2. The second one is simply having find the conjugate of the complex number z is equal to w to the power 3y plus 2ix, right? Where w is equal to x plus 5i. So how do you find the conjugate of this? To find the conjugate of the complex number this, you simply have to make a substitution. So as I said, we always have to negate the complex part, as simple as that. Z now becomes x plus 5i all to the power 3y plus 2ix. Then our complex conjugate is simply equal to x minus 5i, right, to the power 3y minus 2ix, as simple as that. So the imaginary part of our expression is simply negated, and that is all I have for you in this video. See you in the next lesson as I take you through polar representation of complex numbers.